Shall we start? Am I audible?
Yes, sir, you are audible.
Okay. Very good morning to all. Today we have with us Engineer Viraj Voditel to deliver a lecture on role of BIM and CDE um, in carbon footprint calculations. Just to introduce Engineer Viraj Voditel with the participants, I'll just go to the brief bio of Viraj sir. So, Engineer Viraj Voditel has more than a decade of experience in the field of architecture, engineering, and construction. He is the founder and director of Texture, a global BIM consulting firm. He is also founder of Cube, the first made in India BIM enabled construction management platform. And Engineer Viraj holds BE honors civil engineering and MSc honors economics from BITS Pilani and MBA from IIM Nagpur. He is a committee member of, for BIS, board member at Building Smart International India chapter, and part of Indian Digital Twin Tank community. I welcome you, Viraj, on behalf of the organizing committee of this GAN program. And over to you. You can start.
Yes, thank you. Thank you so much. So let me just begin by sharing my screen. Give me a minute. Yeah, I hope my screen is visible.
Yes, yes.
Yes,
Okay, and I hope I'm audible as well, clearly.
yes, perfectly.
All right. Okay, so I think we'll begin. As introduced by Professor Mangesh, my name is Viraj Buditel, and today I'm here to discuss more on the BIM and CDE side and give you a perspective on how digital technologies are being utilized in this space or can be utilized, and what the future looks like in how we can do carbon footprint calculations, and how we can look at the entire life cycle of any project, right from the conceptualization uh, through the construction and operations and maintenance phase, and even towards demolition, and how we can look at measuring maybe carbon dioxide equivalents, or how much of an impact building construction is having on the environment. So that's primarily the topic that I'm going to cover today. So just before we begin, we have possibly about an hour of discussion, and then we'll also have some time for Q&A towards the end. So I'll be introducing, some of the key concepts and key topics, because I suppose not all of you will be familiar with some of the jargons used, in the industry. So I'll cover things from really basics at the start. Then we'll look at the impact of construction on the environment, carbon footprint, and then we'll look at how BIM, or building information modeling, has a role to play, how it can be utilized. I'm sure most of you would be familiar with what BIM is all about, but things have been really advancing over the last a decade or so in this industry, and there's new concepts around collaboration, utilizing design data during construction, utilizing concepts like common data environments. So that's something that we'll transition into after we look at BIM related concepts, and how we can bring in data from different sources and collaborate and integrate everything together. Um, Also, like you might have seen in my title, so I am a co-founder at Cube. So that's a software for construction management, and it also acts like common data environment as well. So I'll be giving you very practical tips and practical insights into how some of these calculations can be done, how data can be extracted from BIM models, and how it can be utilized to uh, you know measure the embodied carbon over the life cycle. And then towards the end, we look at some of the benefits and the gaps and challenges that exist still in the industry, and then what the future looks like, uh, with respect to these technologies. So that's a brief outline of what we're going to cover today. All right, so I'll begin with a quick introduction, and we'll look at a stark statistic, that is 39%. So 39% is a really big number, and this is the percentage of carbon emissions that are being contributed by building construction. So that's really a huge number, and you would see the distribution of it, like 28% of it comes from operational emissions. Uh, you know, when buildings are constructed and actually utilized during the entire operations phase, and then we have about 11% that comes in from construction processes as well as materials. So when we look at building life cycle, we don't really need to just look at the construction phase or the design phase, which typically would take a very small amount of time, maybe small in the bigger picture, I would say, maybe a 2 years, 3 years, 4 years. But the building operations phase is really something that goes on for 50 plus years, maybe even 100 years. And as these spaces get utilized, that's when a lot of impact also happens on the environment. So we'll be looking at both these aspects and what role BIM and CDE can play in all of this. Uh, so what really, tools like BIM help you is to take a data-driven approach. Okay, so like we already looked at the major contribution happening from this particular sector, and unfortunately, or the way we want to look at it, this industry is one of the least digitized. In fact, it's the second least digitized, only after agriculture. So, when we look at some of the emerging technologies, like around artificial intelligence, for example, which build upon existing data sets, one of the things that's really lacking in the industry is uh, having waste sources of data. And one of the fundamental reasons for that is the processes itself are not that digitized. Now, BIM, so we look at both BIM and CDE one by one, but both of these are essentially pointing towards one thing, that how we can take a more data-driven approach to this entire challenge and make the impact on the environment. So I'd like to call it that. There are of course various ways to measure it, and the end goal could be to make it actionable, just like we measure costs. So I like to relate the impact on the environment also as a cost. So when we look at any typical construction project, we always are concerned about the budgets. We are always concerned about the monetary impact. But one thing that we, uh, fail to realize most of the times is the impact that the project is going to have on the environment. So that's why if we look at what kind of impact or what kind of cost it has on the environment and make it actionable, that's when we'll really be approaching things from a data-driven mindset. If you can't really measure something, you can't really manage it. So the way I look at it, BIM models and then these kinds of collaborative environments, we'll talk about what BIM and CDE is in a short while, but this is actually going to provide that kind of a framework where you can start measuring these things so that you can manage them in a better way. So yeah, so that was like a brief introduction about what the topic is going to be. Now I'll speak a little bit about the carbon footprint in construction. So we looked at a couple of terms in the earlier slides. I'll dive a little bit deeper on them. So uh, if we think very fundamentally, uh, there we can divide this impact that we were talking about in two parts. One is the embodied carbon, which is essentially, something that is within the processes or within the materials. So as we see here, emissions from manufacturing. So any material that is getting manufactured, getting transported, installed in a building, and even during demolition or end of life, we are disposing it off. So we are looking at the disposal of building materials. So all of those things consist or compose the embodied carbon. And this image here will, I think, illustrate it really well. So this blue section is where you look at the production or manufacturing of raw materials. So it could be raw materials or it could be any sources that are contributing to it, and then it goes into manufacturing, and then it goes into transportation to the actual site. So this is just an illustration, these numbers that you see here, to give you an indication of how much of an impact these different phases have. It will differ material to material. It will differ, from based on the use case, etc. But like you see, 73% of this is getting, represented within embodied carbon, and then you have the operational side of things when we are looking at energy that is being used to operate the building. So the word building that I'm using here, don't take it to be like just for specific building projects. You can look at any kind of infrastructure projects as well, be it horizontal construction like roads, highways, everything significant impacts on the environment. So the word building here is just like, don't take it just for that. These concepts are just applicable for maybe high-rise buildings or houses or something like that. It's everything that we call as the built environment, and the word built environment is everything that is not the natural environment. Okay, so anything that is part of the built environment that will have similar impacts. Right. So you see the contribution here is lesser from the operational carbon and higher from embodied carbon, but the I would say the duration or uh, the timeline, if we look at it, so the operational timelines are definitely much larger, and with more and more technologies coming in, and with people wanting more and more air conditioning, more and more electricity usage that is there, so definitely the operational phase also has significant impact. So we can represent the entire life cycle of a project, or how materials get used right from the start to the end. So I thought that this kind of an illustration will really help you visualize that. There are also certain technical ways to divide these phases, and there are different standards. I'm sure there have been other talks over the past few days that have talked about some of these standards. There are various ISO standards as well. I'll not go into that. I'm just touching upon these so that this builds into the foundation of some of the later concepts that we are going to talk about, BIM and CDE. So yeah, right from the starting of extraction of raw materials, then transportation. So the transportation and construction could be directly to the site in case of in situ materials. It could be to the factory where manufactured products are getting created, or any prefabrication is happening, for example. So there is a process around that that's happening. Then you have transportation to the end site. Then you have the actual construction process, which will again take place for quite some time. And these materials are getting procured, these are getting manufactured. Everything is happening in parallel over here. So these are not necessarily sequential steps that are happening. And then you have, so after this particular phase, you have the usage and maintenance of the facility. Then, in a lot of cases, and especially with rapid urbanization that we are seeing, uh, demolition is also a very practical use case of, it happens a lot where an existing structure is demolished and something new comes in its place. If you look at, buildings, houses get demolished, high rises come in their place. Um, Different technologies were being used, or construction methodologies were being used to make roads before. Now, the advancement of technologies, roads also get repaired, they get completely redone with different materials. So all of those things, keep on happening in a circular loop. So this is, in this image, it's being represented linearly, but if you really look at it, it's more of, a loop that goes on and on. And certain materials, of course, they cannot be recycled, but with, more and more green technologies and, green concepts coming in, definitely a lot of them do get recycled as well. So, so that was a little bit about, setting the foundations and concepts. Now let's look into what exactly a CDE is. CDE is there in the title of this particular talk. So I'll just, go into the very basics. Maybe not all of you might be familiar with what a common data environment is. So CDE stands for Common Data Environment, or sometimes it's also referred to as a connected data environment. So if you look at it very, very fundamentally, you can just think of it as a centralized repository for all the project data. It could be for a singular project, it could be for multiple projects as well. So these concepts of common data environment have really gained prevalence after cloud has come into the picture. Uh, there used to be, you know, data repositories ever since computers came in and were being used for, designs and creation of, project drawings and all of that stuff. But uh, the word common here is really important. So you can call it as common, you can call it as connected. Why this is important is because it brings all the different stakeholders of a construction project on one single platform. Okay. Uh, we so I'll not go into too much detail there, but I think all of us are familiar with how different kinds of stakeholders. So there are so many different kind of people who are involved in any given construction project. So be it, uh, if you look at on-site during construction, you have people right from, blue-collar workers, laborers, carpenters, you have site engineers, you have project managers. So you have all different kinds of people on the site, and then there are so many other different allied people as well. You have design consultants, you have architects, you have people who are financing the project, which could be either individuals, it could be entire financial institutions, uh, it could be large corporates. So, almost everyone is impacted by the built environment in today's day and age. So many different stakeholders from so many different backgrounds, and all of them have to come together and execute this particular project, right? So everyone brings with them different backgrounds, everyone brings with them, different approaches and different educational levels. So there are so many different things, so many different stakeholders that have to act together for the success of a project. And when we say success, it could be like, completing it within time, completing it within budget, and also with the, topic that we're discussing today, having, minimal impact on the environment, or at least measurable impact on the environment, right? So having this information centralized. So when we say information, it could be any kind of information, be it, uh, you know, designs, be it drawings, be it calculations, be it any kind of documents, be it 3D models, be it BIM models, anything for that matter, needs to flow from, so all this information flow needs to happen between people from all these different backgrounds. So that's where this concept of common data environment really came in. And there's this ISO 19650 that also talks about certain best practices and how information should be shared and how information should be digitized and flowed between all of these different parties. Okay. Essentially, what we are talking of is a single source of truth, where nobody needs to refer to uh, you know or where they can refer to the latest versions of any documents. They don't need to necessarily communicate with each other and leave things to interpretation. But all the latest set of files, the latest set of documents and information is available at all times. Okay, so that's what common data environment really is all about. This diagram that I've put here on the right, uh, this is an excerpt from this ISO standard. Uh, Essentially, what it talks about is that since different people come in at different stages of the project, so they need to have access to different sets of information at different points in time. So, for example, if an architect has come on board, they'll have their own initial set of documents that they are preparing. Some of these could be internal just to the architecture firm. Then when they are ready, they would share those work in progress documents will not be shared. Maybe they'll be publishing those documents and then sharing those with the end client. So that's where we talk about work in progress spaces. And once things are, let's say internally approved, then things move into what is called as shared spaces. Shared could be shared with the client, shared with, some uh, compliance body, etc. And once it is approved further, then it goes into published space where it is then shared with everyone, maybe shared with contractors to do the construction. And then once things are, constructed on site, then you have as-built information that is coming in and things which are verified from the site. And then those again published documents could be further updated and then archived for future reference. So these are just some concepts about common data environment. Now, enough talk. This video will, actually help you understand what a common data environment really looks like. So this is a, project, and within a project, you can, subdivide it into those virtual spaces that I talked about. So these spaces are nothing but, sets of uh, folder structures. So you can think of it like a document management system at a very basic level, uh, but which goes above and beyond, which helps you with file sharing rights. So you can have certain spaces like, in this case, I have opened this space called as BIM coordination space, where only people who want to do coordination on BIM, they have access to it. And you may have specific folders that are created and shared with specific stakeholders. Within that, you may have specific 3D models. You can have 2D files, you can have any kind of PDFs or any documents, and you may have different access control to specific documents as well. Uh, and then each of the documents may have different versions as well, as you can see here in this video. So the reason I'm showing you this video is we looked at the concept of a common data environment, but we are also looking at practically what it looks like. And by the way, this video is like a screen recording of the Cube software. And this is just one of the modules or one of the feature sets that it has. Further, uh, a common data environment is something that also should be able to manage versions. So you should be able to see different versions and which one is the latest. So currently this is version 1, and it says you are currently working on older version of this file. And this is actually a .rbt file, so a Revit file in this case. It could be any kind of document. It could be a file which is made in SketchUp, a file which is made in AutoCAD. The thing that I'm pointing out here is that a common data environment needs to be agnostic. So what that means is that irrespective of what kind of file someone is working with, they should be able to share it with another stakeholder. And Nothing should be, left to, assumption. Things should get translated, be it the model geometry, things, or be it the data that is inside the models. So typically the common data environments which are used in the architecture, engineering, and construction industry, they should be able to, uh, you know, uh, directly visualize these kinds of file formats that are popularly used in the industry. Okay. Yes, so we can orbit around in the model. We can, so we'll look into a bit more details of what more can be done within the uh, common data environment from a BIM perspective very shortly. So let's move on to concepts of BIM. Then we'll, dive a bit deeper into how these things talk to each other, how these things are actually integrated. Uh, Again, I'm sure all of you know what BIM is. So BIM stands for Building Information Modeling. Sometimes it's also referred to as Building Information Management as well, depending on what context you read about BIM. It's also referred to as Building Information Model. So, a 3D representation of a project which is information rich. That's what is called as a building information model. So it's not just a 3D model. So uh, you know, we've seen 3D models since ages, but the concepts of BIM really came to fore when the information associated with each and every object that is there in the model that got embedded inside these 3D objects. And we had those technologies and software that really helped us do that. So some of the popular tools out there to help create BIM models, as they're called, would be Revit. Revit is a popular example. There are other tools like ArchiCAD. There are various other tools as well for structural detailing. Then Tekla Structures is there, and so many other tools are out there which essentially help in creating these BIM models. Okay, and it's again, like I said, could be a representation of any construction project. The word building here is not a noun, it's actually a verb, so it refers to any kind of construction project for that matter. Okay, and the idea is to not just embed uh, the geometrical information into it, which is the 3 dimensions, but also information about time. So how the elements in a building are actually going to come together, in what sequence, on what dates, by whom, all of those kinds of things which typically link construction schedules to BIM models. So that's what 4D is all about. And then you have the 5th dimension, which is the dimension of the monetary cost. So usually I say cost, but since we are also looking at the impact on the environment, and so those again are the dimensions which could take further 6, 7. There are so many other dimensions also that we could talk about in the industry. So what we are going to look at more in depth in the later half of the presentation today is on the uh, impact on the environment. And one of the concepts that we really need to understand is estimation. So estimation in very fundamental terms is, something that, an ability to extract this information from the BIM model and tabulate it. So I'd like to give an example of, cost estimation first, because it's perhaps more easier to understand. So we thought of BIM models as this kind of a 3D model, right? And this 3D model has, like we said, all the geometrical information. So if it has the geometrical information, we possibly can calculate things like lengths, areas, volumes, right? So what these tools today help you do is automatically extract all of this information based on the geometry of the model, So let's say you have a wall and you want to calculate the volume of the wall, or you want to calculate the surface area. So you'll have those dimensions inside the BIM model. And then using software, you can extract the volumes, areas, whatever you want, and then link them to your BOQ items. Okay. So that's essentially how BIM-based cost estimation works. That you have your model objects, you're extracting information from them, geometrical information, and then translating that into volume, area, whatever, and then multiplying it with a rate, and then getting the amount. You do the total of amounts of all of these different items that are there in your BOQ, you get the cost estimate for your entire project, right? That's how cost estimation works. Similar fundamental you can apply to estimation for impact on the environment as well. How that can be done is you can embed information about how much impact the particular element or particular object will have on the environment. And then, of course, we can break it into embodied carbon, we can break it into operational uh, carbon, and so on. So we look at some real illustrations as well about this. So what I'm going to show you today is, these workflows or how these things can be done using the Cube software. You can check it out. We also have a MOU with VNIT, and a lot of training is also being undertaken for students as well. In fact, one of the such sessions is also currently, is being undertaken as well. So so you can think of the common data environment concepts and BIM concepts that we have talked about, and also the estimation related concepts that we looked at as well. So all of those workflows can be orchestrated within the Cube software. And it's something that is completely cloud-based and can be accessed on any device, be it a mobile phone or be it a desktop or a laptop. And it's something that is ISO 27001 and SOC 2 certified as well. Okay. So we look at how all of this information can come together in a common data environment, how we can assimilate things from different sources, and then how we can use that to measure the impact on the environment. So let's look at that through this particular video here. So first we look at some of the BIM related concepts. So this is a 3D model. So this, as you can see here on the top, it's a .ifc file, and we can zoom in, zoom out, we can orbit around, we can walk around as well. Uh, so this is something that is a very fundamental set of features of what a BIM uh, model looks like, or how a BIM model can actually be navigated around. So just like a video game for that matter, you can walk around a project or a design of a project here. Now, these models that we are looking at, these models could possess various different levels of detail, and you can do the estimation of embodied carbon at different stages of the project as well. What we are looking at here is that we've selected a particular object in the model, and all the information, or you can call it the metadata of that particular object, is directly accessible to us. So you can see things like lengths, areas, perimeters, gross surface area. So there are, wall skin thicknesses, so many different parameters that can be modeled inside a 3D model. And this information, a lot of these numbers that you see here are numeric. So this will give you a good illustration of how this can be used for doing uh, measurements, or doing quantification, or doing cost estimation. But similar concepts can also be used to do the uh, estimation of the embodied carbon as well. So not just the geometrical information. If I go back slightly over here, so you can see uh, there is also information about materials. There can also be any kind of information about which user has created this particular object and so on. So it gives you a complete audit trail of the uh, of the objects that exist in the BIM model. Okay. Uh, yeah. But a lot of times in practical workflows, what happens is that this information may need to be enriched because it may not have the embodied carbon information, for example. So we'll also look at workflows on how that can be done as well. So I'll just skip a little bit forward here, but the idea is that we can, select any kind of objects here. We can turn those on and off, so on. So you can essentially manipulate and work with building information in whatever way that is required. And similarly, if all of these things are collaborative, so views can be created, snapshots can be created, which could be used to communicate information between these different stakeholders. So, for example, if I see a particular issue over here, so I can create an issue, I can do different kinds of markups. So essentially, what is happening is it's breaking the borders of communication and helping everyone be on the same page. So these are some of the fundamental concepts of BIM and BIM model on a CDE for that matter. Okay, yes, let's move ahead. Now let's look at the workflow that I wanted to talk about here. Uh, so we typically start with data sourcing. So when we say data sourcing, you have all these different sets of information. So you may have 3D models coming in from architects or different design consultants. And then you may have certain drawings being prepared out of those. Then you may have, uh, you know, manuals or standards or calculations or methods, etc. So all of that documentation. So that needs to all be assimilated in one place. So we start typically with that. Then, so what the workflow that we are looking at here is a BIM-based workflow. So that's why we will be looking at BIM models, which will form part of your sources. Then you have the next phase, which is enrichment. Now, what this particular stage in the workflow is all about is that sometimes the information that exists in the BIM model may not be enough for you to do your calculations. You may want to put in your own parameters, you may want to perform your own calculations and use those to do your carbon estimation, right? Which is something that is more downstream. So to be able to do that, you need to enrich the model and add that information. In practical workflows, what happens is the uh, modeler or the architect who is preparing the architectural model or someone who is preparing the MEP model or the structural model, most of the times they may not be concerned about the embodied carbon, or they may not be concerned about the impact on the environment. That may be done by a separate individual or a separate specialized consultant for that matter. So they will need to come in and enrich the model as well. The third phase is setting up standards. So this is more about defining the rates. So if you look at from a parallel example of costs. So to arrive at the amount, you have to multiply the quantity with the rate, right? So similarly, you may want to arrive at how much would be the embedded carbon, how much would be the operational carbon, and what is the total impact. So all of those kinds of standards you may want to bring in into the platform. And then utilizing those standards, you may want to do the estimation. And then lastly, you do the review and reporting. So let's look at the first part, which is the data sourcing. So here, I'm illustrating by creating a new folder, and then we can bring in different kinds of documents into the platform. So I'm uploading a few set of files over here. So I'm uploading a few Revit and IFC and Navis files. So these files could be of different file formats. Once they are uploaded, they are processed by the common data environments that they become ready for viewing. Parallelly, what I can do is I can create a merged model, which is like a federation of all of these different data sources. So it could be a combination of 3D data. It could be a combination of 3D as well as 2D data as well. So in Cube, you can bring all of these different file formats together into one single source. And you can see over here, I've just paused it, that what are the constituent files that comprise of this particular federated model. Uh, and what the common data environment would do intelligently is that even if there's an update to a certain drawing or to a certain model, it will automatically sync those changes into the federated model as well, so that the version control is kind of automated. And whoever is working on this model, they are always working with the latest set of files, and they don't need to manually keep a track of whether the architect has uploaded a new version or something like that. Yeah, so that really helps her on the latest set of information. Then we can directly open this particular model here as well. So as you can see, this is, so I have just merged a few random models uh, here as well. And so there's a furniture model on top. There's a architectural model at the bottom. So one of the things that is typically required to be done, yeah, now all the models got merged, is to make sure that these are coordinated correctly. So if different different systems or different coordinate systems are utilized, then things get messed up, as you can see over here. So in the common data environment in Cube, we also have a functionality where we can realign these models together so that they appear in the correct locations as well. So there are certain downstream workflows that are used in construction projects like clash detection, for example, or even for general visualization. If things are not geolocated correctly, then of course it may lead to wrong interpretations. So all of these kinds of workflows can be done within the Cube software, so that the data sourcing that you have done and you have federated all the information together in one place, that can also be validated and checked that everything is everything is correct, and then it can be used for subsequent workflows related to, let's say, estimation or clash detection and so on. So yeah, so I'm just updating a few um, parameters here, like the Z of this particular model, and it's, as you can see, it's moving here in real time. And you can save this save this information so that next time onwards the models are geolocated correctly. Yes. Now what we'll be looking at is, yeah, we have opened a particular model here. Yes, so we saw that all the different metadata or information that is embedded inside that particular model also is available in the software, right? But sometimes you also want to add certain custom metadata. So here, like what we have done is we have added a section called as environmental parameters, and there's a field for embodied carbon that can be added. So this could be a numeric field, this could be a text field, it could be a date field. So what the platform enables you to do is, uh, put in any kind of such information also into your model objects, which may not necessarily be available within the model by default. So this is what is the model enrichment stage, which I was talking about. And then what can also be done is we can create these kinds of queries. So this is nothing but think of it like a search engine for your model. So we can, define different conditions. So it could be a very simple condition, like I want to find all the objects of a particular category. So category equals, let's say, yeah, structural foundations in this case. So we can Click on show results, and what it will do is it will isolate those objects for you and also list them out, on the left. So essentially, your BIM model is nothing but a giant spreadsheet of your information that is embedded inside the 3D objects. So what you're doing here is kind of performing searches or queries on top of that. We also have certain, AI-based algorithms over here where, just even if you type it in simple language, it will return these results for you. Or you can create or build complex queries using the query builder, using the and/or rules. So why this is useful? So this, what we are looking at here is the more into the process of estimation, where we want to filter out certain objects and then do the enrichment. For example, all of these are, let's say, created from M30 concrete, and all of them we want to enter a single parameter, like what we looked at over here, the embodied carbon. We added it for just one element in this case, but suppose we want to do it for all together, a specific set of elements. So you can filter it by, columns on the first floor, or, plinth beams, things like that. So with these kinds of queries, you can quickly filter your model and enrich it the way that is required. Yeah. So as you can see here, for all of these objects together, we have added uh, added this particular value. So this was the model enrichment phase. Then the next thing that we want to look at is how we can associate this information that we have added. So it could be the information that is already present in the BIM model, like volume, for example, or this embodied carbon that we are adding over here. So what we have done in this case is it's just very similar to how a bill of materials or a bill of quantities would look like. But instead of looking at a currency, a monetary currency, we are looking at embodied carbon here. How this rate and amounts are going to appear here, that also I'll quickly dive into uh, in this particular video as well. So what we have done here is that we have linked or associated the files. So it could be one file, it could be multiple files. Here, to keep things simple, we have just associated one file. And the query that we looked at in the previous video, we're just going to be creating a similar query here. Yes. And I'll just skip forward. Yeah. Then what can be done here is that you can link this rule. So query is nothing but a rule. So you can link that particular rule to takeoffs. Why we usually want to do this in BIM workflows is that BIM models change very frequently. There are like new versions coming in, changes coming in, and you don't want to do that, exercise repeatedly. So what can be done here is, so yeah, what we are doing here is we are attaching the query that we just created, and we are associating a certain parameter. So this parameter could be, in this case, we are doing volume, and we are associating the volume over here, and it has extracted the entire total volume, and we can convert it into whatever unit we want as well. And we can associate this particular set of objects to an item in our bill of quantities. So if I just forward it a little bit over here, so this 50.92 is now associated with a particular item over here. As you can see, it highlights it in gray color, which defines that these quantities are actually coming in from a BIM model. Okay. And the unit is also captured. Now we look at, once this kind of information is extracted, how we can arrive at a rate. One second, let's look at this part first. Yes. Yeah. So for a particular item, you may want to define that for 1 cubic meter, of, let's say, M30 concrete, how much is the impact or how much is the embodied carbon it has uh, based on its constituent materials, based on transportation, based on placement, vibration, formwork attribution, and then arrive at this particular rate. So just like we do a rate analysis for costs, you can do a rate analysis for embodied carbon here as well. And it could also be through variable rates. So yes. So you may also want to define, things around transportation, for example. The rates may be differing based on, the range. So from 0 to 25 kilometers, you may have a different rate. For 25 to 50 kilometers, you may have, a different rate per kilometer, for example. So all of these kinds of things can actually be defined within the software so that you can arrive at a very accurate estimate. This we have already looked at. Yes. So there is a question about. One second. Let me just pause this. Yeah. So there's a question about database. Which database is being used? Is it already embedded? Yes. So this part I did not cover in the video here, but all the information that is coming in is so you can create your own databases within the software, and you can either import it from an existing spreadsheet or you can directly create it within the software as well. So it's flexible in terms of databases. You can define your own databases as well. Okay. Then moving on. So one last aspect that I wanted to touch before I close is that we talked about the concept of different stakeholders being collaborating on the same platform. So since this is entirely cloud-based, so different users can log in and access the same set of information. So you can have someone uploading files, you can have another person, enriching, doing the model enrichment, another person doing the takeoffs, another person doing the entire calculations. So all of these roles can be played by different people on the same set of data together. So sometimes these workflows need to be collaborative. Everything needs to happen in real time, which can be done. Sometimes these things need to also happen in a stage gate manner. You don't want someone making, changes incorrectly. You don't want someone reviewing the wrong set of information. So for that, there are also workflows that can be orchestrated for approvals and reviews. So let's say model enrichment has been done before estimation actually takes place. You may want to get that reviewed, that set of information reviewed from a higher up. So even those kinds of workflows are also part of the common data environment itself. So here in Cube, we can define, different levels. Like there's going to be an initial review of the model, and there's going to be a BIM coordinator who's going to review it, and there's a manager who's going to review it, and then the project manager will ultimately give a go-ahead. So these kinds of levels can be defined, and different users can be defined that who is going to review and approve at different stages. And this kind of a visual workflow of different statuses, that first the file will be in open status, then it will be in review, then it will be approved. No one will directly approve it. So those kinds of things can also be done. So here I have attached a few models here, and then I can go ahead and initiate this particular review, and then people will get notified. So the reason I'm showing you this is that communication and coordination and collaboration is something that is very fundamental. Most of the tools that used to exist a few years ago, they used to talk about doing this kind of estimation in isolation, right? But now with connected workflows coming in, these things need to be baked into the entire process as well. because that's how things happen in reality. So if, let's say, you are using a 10-year-old software on your desktop, you did the estimation and you send that file to someone and they approved it. But then, when you were doing the actual estimation, you realize that there were, a few things that you did wrong in the model or in the estimation. Then, you will do those changes. Maybe those may not get communicated to the person who has approved it. So those kinds of things will now become a thing of the past with these kinds of connected workflows. So I'm almost out of time. So the last couple of sections, I'll just use to run these slides very quickly in the next 2-3 minutes, and then we can, open the floor for Q&A the next 5-10 minutes. So we'll look at some of the benefits and challenges of these approaches. So one of the biggest benefit, I would say, is bringing in transparency. Uh, if you have all the information on one single connected platform, then of course things will become more transparent. People will have access to the latest set of information. There'll not be a game of Chinese whispers that will happen. This, of course, has a flip side where you don't want things to be very transparent, with a simple example being that the conceptual drawings that an architect has created, they may not want to share all the design options with the end client. So it needs to have access control. It needs to have stage gate workflows as well. Okay. So when we say transparency, it's not that everything will become accessible to everyone. Uh, of course, the right set of information needs to be in the right set of hands. That's what we mean by transparency over here. Okay. Then single source of truth, we've already talked about this, early design interventions. So uh, we looked at one of the workflows. I mean, we didn't go into too much detail here, but the queries that we linked with the model objects and with the the carbon estimate that we were preparing. So that can actually be replicated across different files as well. So assume that an architect has created 3 different design options. So not just the visual differences, but you can also look at differences in the impact that each design option has on the environment as well. So that can help in taking these kinds of decisions early on. And if we can take decisions early on, then we'll be able to minimize impact as much as possible. Then the second set of benefits is around compliance and automation. So there are like different bodies out there, different certifications out there for buildings. So there are there's LEED in India. We have GIHA. There's IGBC. There's so many different kinds of bodies, and so one of the commercial benefits, I would say, which people see as having their project certified. Now, when you want to do certification, when you want to do compliance, you need to, of course, have documentation in place. You need to be able to prove your calculations. So, with the use of BIM, with the use of having information in one place in a CDE, all of these things can be automated to a very large extent. Okay. So, uh, so yeah, I mean, if you do things manually, if things are not integrated, then of course there are a lot of challenges that come in. But with the use of these technologies, the entire documentation processes around compliance can actually be automated, and you have audit-ready information because you have the full logs of each and every action, each and every activity which every stakeholder has been doing. So be it very simple activities like uploading information, to be it model enrichment, to be it the estimation part, everything is tracked. Every micro interaction is also tracked in Cube, for example, where even if you just create a single query and attach it to an item. So that gets registered with the timestamp in your name. Okay, so even if you have to do an audit at the towards the end of the project, then you can always come back and see that at what time who had done that. Of course, what all of this leads to is faster decision making, cross-functional collaboration. So I think we already touched upon this aspect of how different stakeholders are there from all of these different backgrounds and how they need to collaborate together. And that is very challenging if you don't have a single source of truth here. Also, what can be done is, because now you have all of this information in place, uh, this can be rooted into business intelligence applications, BI applications, like, for example, Power BI, something that is popular. Even in Cube, we have the functionality to embed Power BI dashboards or create your own dashboards, where this set of information can be plugged in and can be visualized in various graphs, charts, etc., which help even non-technical people to make decisions in a more informed manner or faster. Okay. And something that is, a bit of a softer concept, which is that of culture. That yeah, if we deliver projects using these methodologies, then it builds a certain culture. And if you can integrate these kinds of requirements of carbon emission estimation, and if you can actually have people playing these roles and delivering these kinds of reports, it would definitely encourage a culture of sustainability and help in shifting the mindset of stakeholders who don't have much awareness about these concepts, and it will definitely increase buy-in. So some of the challenges and gaps that exist today. So during the early stages, of course, things are not that detailed. The models that we looked at, those models also progress. There's a concept of level of development. At the early stages, of course, you won't have, very detailed model objects that are created. So the estimations would be rough. Similarly, the databases that you're utilizing. So during the early stages of design, you may not want to get into too much detail. So that's a bit of a challenge here. Then you have low interoperability between different tools and formats. So a lot of these challenges are also getting solved. It's not that these challenges exist in their purest form today. Most of the tools, like in Cube, for example, we support more than 30 different file formats that exist, that are being utilized in the industry, and you can federate them all together as well. Even 2D and 3D can be federated, for example. So those interoperability challenges are getting mitigated, but there do still exist some of the challenges. And there are certain standards like IFC in from BIM perspective that are helping bridge these interoperability standards. Then things about literacy about these concepts. Uh, so most of the project teams, they are not aware of a lot of these concepts. In fact, uh, if I have to tell you by experience, people don't even use these kind of systems for cost estimation, which at least commercially has so much more impact on each and every stakeholder. So even these systems are not being fully adopted uh, for those workflows. So definitely for sustainability workflows, things will take slightly more time. So there are challenges around that. uh, Indian context standards, benchmarks, these are also limited. We have to rely more on Western standards, which may not necessarily be completely adaptable, but definitely I would say those are good starting points. And we should not use this as an excuse to uh, not implement workflows in our projects here in India. And as with any kind of new changes, that come in. These need to be top-down driven. It just cannot happen at grassroots level automatically. Things need to be driven from governments as well, through mandates and through project owners, through their consultants, and then to the contractors, and so that everyone is on board with these kinds of workflows. So I'd like to end with what the future looks like. So things are rapidly changing in the technology domain, right? So the way we visualize, the way information. So I remember a time when we used to, whenever a BIM model was updated, we used to export spreadsheets out of it and then, manually patch together an estimate. Now things have so rapidly changed. We looked at an example of how you can link information from the BIM model in real time dynamically to the estimate. Similarly, you can link that to dashboards as well. That if any change happens in real time, that is reflected in the dashboards. Then you have artificial intelligence coming in, be it generative AI or uh, be it algorithms for analysis. There are so many things happening at a very, very rapid pace in this particular space. So we are looking at how all of this estimation that I illustrated in the form of a video. The same thing could be actually done by an AI agent as well, provided the right set of inputs and programming has been done. Then things about taking it as early as possible and also utilizing it as late as possible. So with concepts around digital twins, where even post construction you have sensors and you have technologies that are reading the information of the built environment in real time. So now that information can also be plugged in, benchmarked, and then analyzed. And more on the mandate and policy front. So in my experience, what I've seen is in India, this is a bit slow, but definitely we'll see more and more government mandates come in. Things are brighter on the transportation industry. We are seeing so many things around EVs in India. I'm sure there'll be more and more initiatives around buildings and construction as well. So, so my parting thoughts, I'd like to part with these thoughts that we need to look at more of integrated workflows rather than work in isolation. That's where use of BIM needs to be increased in projects. More and more projects need to be having a common data environment. And to be very honest, this trend is happening in all practicality. We are seeing more and more projects adopt BIM, or even if projects are not on BIM, a lot of our customers who are utilizing Cube, they're entirely using 2D workflows. They are still using common data environment. So it's not necessary to use BIM with CDE, or BIM is not a prerequisite for a CDE. Bringing everyone together on the same platform is just such a fundamental thought. So that is something that can be done with any set of data. It's not just for high-end projects. Okay, so we need to use more and more such tools, and that's where I think the future lies, that we can help this decision making to be much faster. So that was all from me. Thank you so much for your attention, and you can write me an email or ask me any question even right now. Thank you. Thank you so much.
I request participants to post the queries in the chat box. So, Viraj, there is some query. Can you share or present any sample report of real-time projects carbon footprint analysis performed using Cube or any other BIM
tool? Yeah, I don't have anyone handy at the moment, but I think we can definitely take this offline. In fact, through this collaboration that we have with VNIT, we are definitely wanting to encourage at least a couple of students to, you know, utilize Cube on a real world project. So like I myself at least have not used uh, this entire end-to-end workflow on a real project. I would definitely encourage someone to take up this as a research project, and we'll be happy to provide access to Cube to undertake this kind of project.
Yeah,
Definitely.
so I may also add up something in this because already I think yesterday there was a presentation or a talk from Mr. Srirang, and we already had a word where Srirang is already working with Open LCA. So we are trying to integrate Cube and LCA. Very soon we will come up with something better wherein Cube data, if that can be imported directly into the Open LCA, that will help for both the things, because that is the only purpose of connecting VNIT and Cube together for research as well as dissemination activities. So there's one more query, Viraj.
Yes.
If an agency want to go in CDE, is there any prerequisite for that?
Yeah, so typically how it happens is CD is either procured by the project owner, and then all the agencies within the project are given access to it, or the individual agencies have their own logins, and they give access to others. So the model works in various formats, from a practical perspective on whatever works for that particular project. So in terms of prerequisites, it's probably just access that they require, and they may require a bit of initial training on how to upload information, how to uh, you know uh, how to review it, how to access it, all of those kinds of things. So typically that's the prerequisite, because a common data environment, like you might have also realized, is something that's not very it's not rocket science. It's very simple. Fundamental concepts are there. So even with very basic prerequisite training, anyone can get started like in just a couple of hours. So I hope I answered the question.
Yeah, perfect. So I hope all the queries are answered, and let us conclude. Yeah. So there is someone in physical mode. Yeah, please.
Hello, Raj. Good morning.
Yeah, morning.
Raj, this side Abhishek. I have three questions for you to answer. My very first question is related to the LOD requirements for the calculation of carbon footprint. Can you highlight something on
Sorry, I didn't hear you properly.
that? Okay. Am I audible now?
Yeah.
Yeah. Whereas my question was related to minimum LOD requirements for calculation of these carbon footprints. Are there any minimum requirements for LOD?
Yes, definitely. So if we look at BIM-based workflows, then you need to have firstly a BIM model that is good enough to be able to do this kind of an estimation. So that's one major prerequisite, because the quality of information in BIM models, you know, your estimate will be only as good as that. If there are any errors or mistakes or quality issues in your inputs, then your outputs will definitely be not correct or not of the appropriate quality. So that is a major prerequisite in a BIM-based workflow. So the entire idea is that you do more work in the design or the initial stages of creating the model, and then you spend less time in doing the calculations and the estimation. Most of that part can be automated. Your effort can go into creating more accurate inputs and linking the right databases and sets of information. So yeah.
Okay, and since you in any BIM environment, we generally talk about federated models. So, what is your take on what team holds the maximum bandwidth or the opportunity to influence this carbon footprint? Is it architects, structure people, or MEP people?
Uh, I mean, it's difficult to answer that question because each of these different disciplines will contribute differently. and at different stages of the project as well. Uh, I mean, if you look at it from a materials perspective, then of course the architects will have a bigger say in what materials are to be utilized in terms of sourcing and procurement. You know, the contractors or the project owners will have a say whether they want to be actually procuring more local materials or, imported materials, so on and so forth. So, and similarly, like MEP consultants or MEP contractors will have a more say in what kind of systems are being utilized to do the air conditioning, ventilation, etc., etc. So those impacts uh, may turn out to be quite high for certain kinds of projects like data centers or hospitals, etc. Whereas if you're looking at more residential kind of projects, maybe the architects have a bigger role to play over there. I would say, even with materials like steel, concrete, which comprise of which have a high cost impact as well as a high environmental impact. So I would definitely not discount the role of structural engineers as well in the entire process of choosing the right design mix and the right materials for the structural components.
Yeah, totally agree with that.
Hmm.
And then my last question is related to, like, since in your presentation you have mentioned about the embodied carbon, and for any infrastructure projects, we are seeing that embodied carbon contributes closely to 70%, right?
Sorry, I couldn't hear you again properly.
I'm saying that in your presentation you mentioned about embodied carbon and transpiration and other sources of carbon that comes to any project. And in your presentation, it was shown that embodied carbon contributes somewhere close to 70% to the project.
Yeah, you're talking about that image, I believe, somewhere. This one?
Yeah, it was somewhere. So my question is related to
This
that.
one.
Correct, this one. So
Yeah.
in this, my question is that since we are talking about a major proportion that goes as part of embodied carbon, what is the break-even that BIM-based workflow can bring, or can bring to the project by being employed for a project? Because running a BIM environment itself will contributes to the embodied carbon there.
Yeah, definitely. So firstly, like I said, when I was explaining this slide as well, that this is just an illustration for a particular kind of material. These percentages will vary significantly depending on the kind of material, the kind of process that is being employed, and maybe even the location of the project and so on and so forth. So all of these things will have an influence on that. Now, if you look at it from a break-even perspective, uh, I mean, see, the projects will have, like, I think you also said this, that if you are deciding to do any kind of construction, it's definitely going to have some impact uh, on the environment. Okay. What we are talking about here is the delta, or, the improvement that can be done. We are not talking about, like it's shades of gray. It's not like 0 or 1, right? So whatever processes are being employed over here is to definitely uh, improve the efficiency of construction, improve or reduce the impact that that our processes will have on the environment. So I'm not an expert in this particular topic, so I'm not very sure what the concept of break even would really even mean in this particular context. So
That's thanks for taking that. But yeah,
yeah.
I totally agree. I totally about the data change what we are trying to bring to the project. Yeah.
Right. It's more about the delta here rather than, I would say absolute impact.
Yes. Thanks
Yeah.
much.
So fine, let's conclude the session 1 of day 4 because next session will be conducted by again Anil sir, who will be again in time, maybe in another 10 minutes. So let's quickly break for 10 minutes and then we'll rejoin, or there's a separate link which already is shared in the group. So please join that group by 10:30. And thanks a lot, Viraj, for your time and sharing the valuable information. I request all the participants, why we are putting different stakeholders on board, because it's not only that outside expert, but in India also we are having a lot of support from various agencies with whom you can be in touch and then see that how that can be beneficial either in your projects or for your R&D activities. Thank you, Viraj.
Thank you so much.
We'll be in touch. Bye.